Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're talking about scalar and vector quantities. So basically it's a series on vector quantities, but I'm going to do a quick introduction here, all right? So before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. All right, so we're going to start quickly. Generally, when we have physical quantities, they can be divided into two main groups. You can talk about scalar quantities or vector quantities, all right? Now, the major difference between both of them is that the scalar quantities just have a magnitude, so that means they can be described using a single number. So for instance, you can have temperature, you can have Celsius, or you can have Fahrenheit. So they're described using that single number with appropriate units. So for instance, you can have temperature like 3 degrees Celsius, or 3 Fahrenheit, okay? Or you can have volume like in 3 cm cube, 4 dm cube, and the rest of it. Now, but a vector quantity is defined completely using both the magnitude as well as direction. All right. So when you talk about acceleration, maybe meter per second squared, a car is accelerating at a 5 meter per second square in the direction of northeast. Does that make sense? Or in downwards direction or in the upward direction. So when you're talking about acceleration as a vector quantity, you have to talk about the magnitude as well as the direction. Now, because I'm aware that students do take note, I'm going to write what I just said so that you can take note, as well as it's going to help you during your revision time so that you know what to do. So the first thing I said was that physical quantities can be talked about in two ways, the scalar and the vector quantities. So I'm going to talk about the scalar first, or I'll just talk about both of them at the same time. So we're going to have number one, the first thing is that physical quantities. Okay, physical quantities can be divided into two main groups. Okay, so we have the scalar quantities, and number two, we have the vector quantity. So basically, there are two types of quantities that we have, or the physical quantities are broken into two types, that are the scalar quantities and the vector quantities. All right. So what I'm going to do is that I'm going to start with the scalar quantity. All right. Just a quick one about the scalar quantities. And after that, I'm going to move to the vector quantities. All right. So the scalar quantity, like I said, they just have magnitude and no direction. So basically, they can be defined using a single number with appropriate units, okay? So scalar quantity, or let's say a scalar quantity. So a scalar quantity is one that is defined completely by a single number. So some people call it magnitude, okay? With appropriate units. Okay? So the first one, you can have length. Okay, types of scalar quantity, we have length. The other one I talked about, you can talk about area. Okay, area is also a scalar quantity. And that scalar quantity you can have volume. Okay, volume, you can have it in cm cube, dm cube, length, meters, kilometers, area. meters squared. Another one you can have is mass. Okay, mass is a scalar quantity. You can have it in kilograms, you can have it in pounds. Then you can also have time, okay, in hours, in seconds. Then you have temperature. You can have temperature in Celsius, in Fahrenheit. So it depends what appropriate unit you're working with. So they just have magnitude without direction, okay? So that means we can say they are denoted entirely by its size or magnitude. Okay, so this one that denoted entirely by its size or what? Or magnitude. So that is that for scalar quantity. Now, let's quickly move to the next one, vector quantity. Now, like I said, unlike scalar quantity, a vector quantity is defined with both magnitude and direction. So that means it's completely defined when you know not only the magnitude, but you also know the direction in which it operates. So it's very important. Vectors have both magnitude and direction. So a vector quantity is defined completely when we know not only its magnitude, so with appropriate units, so we already established that. So when you're talking about magnitude, it has to be with the appropriate what? Units. But also, you need to also talk about the direction in which it's operating. Okay. So for example, you can have force, okay, which you can have it in Newton. You can have velocity, meter per second. You can have maybe acceleration in the forward, maybe accelerating northeast or towards the south. Okay, so you have direction. Another one that you can have as well, unlike mass, that was a scalar. In this case, you're going to have a weight. So the weight here is the velos. The weight here is the vector quantity, I beg your pardon. So now, therefore, we can now say, similarly, but a little bit different, is that you have a magnitude like the scalar, but you're going to have direction. So therefore, they are denoted. So they are denoted by both magnitude and direction. Are denoted by both magnitude and direction. All right. So here we're going to talk about vectors. Like I said, I'm going to only focus on vectors in this video series, okay? And I'm going to talk about things like vector representation. I'm going to talk about how do you add or subtract vectors. I'm going to talk about the concept of components of vectors. How do you get components of vectors? I will talk about the magnitude of vectors. I'm going to talk about magnitude in 2-dimension or 3-dimension. I will talk about how do you multiply vectors. We'll talk about the scalar or dot product. I'll talk about the vector or cross product, okay? Then I'm going to talk about the angles between two vectors and the direction ratio. So I'll talk about all the 6 concepts in this video, all right? So I'm going to write it down here so you can take note of it. So that's why it's very important that you subscribe and click the notification bell so that when I post these videos moving forward, you'll be the first person to know. So here, we will discuss only vectors, okay? And we'll include the first thing we'll talk about vector representation. So how do we represent vectors? Number 2, we'll talk about addition of vectors. Number 3, I'll talk about component of a vector. Number 4, I'll talk about how do we multiplication of vectors. So under multiplication of vectors, I'm going to talk about 2 things. The first one I'm going to talk about is going to be scalar or dot product. So I'm going to show you how to do scalar or dot product of vectors. Then the next one I'm going to talk about vector or cross products. Okay. Then number 5, I'll talk about angles between 2 vectors. And the final one I'm going to talk about the direction ratios, okay? So these are the 6 things I'm going to talk about. I'll talk about the vector representation, how to represent vectors, the addition of vectors, the component of a vector. We talk about the x component, the y component, and the z component. I'll talk about the multiplication of vectors. I'm going to talk about the scalar dot products, okay? We talk about vector or cross products, the angles between 2 vectors, and direction ratio. There are more things, okay? But for this video, I'm going to just stop in this video series. I'm going to just stop at direction ratios. Maybe when I have more time, I'm going to talk about more concepts later. All right. So this is going to be the basics or the foundation for you to build on in understanding the concept of vectors. All right. So as you can see, I'm going to go straight to talk about the next video will be on vector representation. So it's important that you subscribe and click the notification bell so that when I post the next video on vector representation, you will be the first person to know. All right. So I'm going to see you soon, and I'll see you in the next video where we talk about vector representation.